Okay, year 8. So last week we learned all about acids and alkalis and pH and using indicators to tell what pH solution is. So today we're going to carry on and we're going to talk about the reactions between acids and alkalis. But first we need to talk a little bit about some terms that we're going to use. So I've written here a sentence that alkalis are a type of base. So last week we talked about alkalis and we said that they had pHs of above 7 and that they're the chemical opposites of acids. Now alkalis are a type of base. All right, now a base is a chemical that neutralizes an acid. All right, so we'll talk about this idea of neutralization in a moment, but so a base, you might have thought before that what I'm saying a base is, you might have thought that was an alkali. Okay, but actually an alkali is one type of base, and it is the type of base which is dissolved in water. Okay, so all bases will neutralize acids, and alkalis are one type of base where the base is dissolved in water. Okay, so just to make that clear, you can have, imagine that this circle represents all bases. That circle represents all bases. Now, some of those are solids, and some of those are dissolved in water. Okay, now the ones that are dissolved in water, these ones here, these ones are the alkalis. Okay, so alkalis are part of all the bases, the ones that are dissolved in water. All right, so in a moment we're not going to be talking about the reaction between acids and alkalis, we'll talk about the reactions between acids and bases. Okay, so when acids and bases react, they produce a neutral solution. So up here I said a chemical that neutralizes an acid is called a base. And that's because when they react together, they produce a neutral solution. And you should know what I mean by a neutral solution because we did it last week. And it is a solution which has a pH of 7. Okay, so acids, these guys here, these have pHs of less than 7, and bases, these guys have pHs of greater than 7, and when they react together they're going to produce a neutral solution which has a pH of 7. Okay, when we're in the lab we'll be able to do some of these experiments and you'll see how it works. All right, now we can test whether or not this happens, okay, by using an indicator. Okay, so obviously when we react these together, remember like last week when I said we had these acids and alkalis, you can't tell the difference between them because they're both colourless solutions. Well, if you do the reaction between an acid and a base and produce a neutral solution, you can't tell the difference because they're all colourless solutions, okay? But an indicator can be used to show that this has happened. Okay, and we'll do some examples of that in the lab. But for now, we need to get some practice in and how to write these equations out. So what I've got here is I've got 3 reactions, okay? They all follow the same pattern. So an acid plus a base makes a salt and water. It's always exactly the same. All right, so anytime you see an acid and a base reacting together, you know that it's always going to be a salt and it's going to be water. Okay, now the only tricky part is what's the name of the salt? All right, so if we look at this first example, the way we name the salt is we take the name of the metal from the base, and that's the first part of the name of our salt, sodium. And then we take the name of the acid. In this case, it's hydrochloric, and that tells us that it is chloride. So whenever you see hydrochloric acid, it's going to make something chloride. Okay, and this is a salt because we have here, this is a metal, and this is chlorine, which is not a metal. All right, but it's sodium chloride, and that has the formula NaCl, and that's the salt that you put on your chips. So if you go to your kitchen now, open your cupboard, take out the salt, that's the salt that's in that jar. Okay, sodium chloride, which can be made by mixing an acid and a base. All right, and then of course we always have to add on water, because that's always made as well. All right, now if we wanted to, we could write out the chemical equation, which would be HCl, that's my hydrochloric acid, plus NaOH, that's my sodium hydroxide. Remember, this is one sodium, one oxygen, one hydrogen. And that's going to make me NaCl plus H2O. Is that equation balanced? Yes or no? Yes, it is. I've got one sodium, one chlorine, one chlorine, one oxygen, and two hydrogens, and two hydrogens here. Okay? Excellent. All right, so that's our first example. All right, let's do a second example. So my second one is nitric acid plus copper oxide. All right, now we're going to name the salt in exactly the same way. So we take the name of the metal from the base, and that tells us the first part, so that's copper. And then we take the name of the acid. Now in this case, it's not hydrochloric acid, so this won't be copper chloride. It's nitric acid, so this is going to be copper nitrate. So nitric acid gives me a nitrate. And of course we have water. Okay, and our final example is sulfuric acid plus lithium hydroxide. All right, so again, you take the name of the metal from the base, which is going to be lithium, and we take the name of the acid. Now it's not hydrochloric acid, so it's not going to be lithium chloride. It's not nitric acid, so it won't be lithium nitrate, but it is sulfuric acid, and sulfuric acid gives us sulfate. Okay, and you can see that all these are the same. It's an acid plus a base, and these are all salts, all named in the same way, and then we always have water on the end as well. So we can summarize how to name these salts. Okay, if we look here, all right, hydrochloric acid gives me a salt which is a chloride. So it'll be something chloride, sodium chloride, lithium chloride, potassium chloride. Nitric acid gives me a nitrate, and sulfuric acid gives me a sulfate. Now, you might want to put that onto a flashcard. All right. In fact, I think I might have one here, if I can just, here we go. All right, so hydrochloric acid makes, and then on the reverse side, chlorides. Okay, and then the same for nitric acid and sulfuric acid, make nitrates and sulfates. Okay, so make yourself one of those. And you should also have this reaction on a flashcard. Acid plus base gives you salt plus water, so you can remember that. So yeah, acid and base on one side of the flashcard, salt and water on the other side of the flashcard. Right, so I've got here 3 questions for you to do. So you need to now, in a second, pause the video and then fill in the gaps. Fill in those gaps. All right, off you go. Okay, so here are the answers. Hopefully you got all of those right. So for the first one, it's lithium is the metal and it's hydrochloric acid, so it's a chloride salt. Then we have, well, we know that it's potassium hydroxide because I gave you that, and it's a nitrate, so it must be nitric acid. And then here, you have to tell me both. So if it's magnesium, you would have had magnesium hydroxide, and if it's a sulfate, you must have used sulfuric acid. And then, of course, all three give you water as well. All right, so finally, there's one last thing that I want to talk about, okay, and that is, how does pH change when you add acids and bases together? So, how does pH change when you add acids and bases? So what I've got here is, imagine this is a beaker with an acid in it, and then I've got another beaker which has got a base in it, and I'm going to pour this in. All right, so it's going to go in nice and slowly, and I'm going to measure the pH. All right, so imagine I've got a special pH probe that tells me the pH. All right, and I'm going to plot a graph here of volume of base added against pH. So what's going to happen? Well, right at the start, I've only got acid. So there's no base at all, I've only got acid. All right, and the pH of an acid is below 7. So imagine this is 0 down here, and this is going to be 14 up here. So at the start, my pH is going to be really low, because it's an acid. All right, and then as I add the base, not a lot happens, because we've still got a majority of acid. So as long as the acid is in majority, not much happens. But then as I add more base, all right, it starts to neutralize. So the acid starts to be neutralized, so the pH starts to go up. And then with these reactions, what you find is that it will shoot right up. Okay? And then here, this is going to be our pH of 7. So, once I've added a certain amount of base, I've neutralized all the acid, so there's no acid in here and there's no base, they've neutralized each other. Okay, like in the reactions we just talked about, they've neutralized each other, so there's neither acid nor base, so the pH is 7. But then if I keep adding more base, what's going to happen to the pH then? If I add more base, and the pH of a base is above 7, then this is going to go up. It's going to keep going up if I keep adding more, and eventually it will start to flatten out like that. Okay, so that's what happens to the pH. And then here we know we've got our neutral solution. So if I don't add enough base, it's still pH less than 7, it's still an acid. And if I add too much base, then it's pH more than 7, so it's a base solution. All right. Good work. All right. So make sure you've got all those notes in your book. Make sure you've got the flashcards as well. See you next time.